A boat departs at 9 a.m. traveling due east at a speed of 15 miles per hour. That is important. At 1 p.m. it adjusts to the course at north 78 degrees east. It reaches its destination at 3 p.m. How far is the ship from its point of departure, and what bearing should the ship have taken? Okay, so here we go. We know that it travels 15 miles in 1 hour. And until it changes direction, it goes a total of 4 hours. 9 to 10, 10 to 11, 11 to 12, 12 to 1. This is 4-hour difference. So if it can go 15 miles in 1 hour, 15, bless you, 15 times 4 is 60. So we're going to go 60 due east here, and this is 60 miles. And then it changes direction. It goes north, so I'm making a right angle here. It goes north, and then it's going to swing to the east at degrees of 78 degrees. Now, how far does it travel this way? It travels for 2 more hours. It travels for 2 more hours from 1 to 3, which is 2 more additional hours. So 15 times 2 would be 30. So 30 more miles in this direction before it reaches its destination. So what is this particular angle? This angle is 90 degrees plus 78 degrees. So let's put that down on our paper. So we can easily probably do this in our head to get 168 degrees. That is that angle. We want to know what is this part, and I'm just going to call this C. You could call it any letter that you wanted, but one of the questions is how far is the ship from its original point when it gets to its destination? So how far is it? So I'm going to say C squared equals A squared plus B squared minus 2AB times the cosine of C. I have all this information. So here we go. I'm going to plug it in all at the same time. I'm going to call this my A. So 60 squared plus 30 squared minus 2 times 60 times 30 times the cosine, make sure you're in degrees, of 168. Then that's what C squared is equal to, 8,021.3. Now I need to take the square root of that, so I'm going to just take that and copy it into place, and we can see that this length is approximately 89.56 miles. So that's the first part of this. That's this distance. But now the second part is, how would I actually get to this? I'm going to put it on pause. You're going to go back to your partner. What would be the actual bearings that they should have taken? That's what I need to know is, what is going to be the bearing to get from the ship to this destination in that direct? Well, first of all, I know that I need to go directly north first. Okay, I need to go directly north. So I know that's the first thing. And then I'm going to fill this in with a value, and then I need to go to the east. I need to fill in that value. So I'm making a right triangle here. Now I'm first going to figure out what is this angle using the law of sines. So this angle is 168, so the sine of 168 over the value of the length of the triangle opposite equals, now I'm going to go with this, and I'm going to call this B for boat, or X, whatever you want to call it, sine of this unknown over a length of 30. So let's cross multiply. So I have the sine of 160 times 30, and I'm going to divide that by 89.56, and I'm set that equal to the sine of B. Here we go. Sine of 168 times 30 divided by 89.56. Now to figure out this angle, I need to do the inverse sine. How many of you got a really small angle of 3.99? So that's this part. But hold up here. Remember, when we find the bearings, we're going to go directly north, and then we're going to swing to the east in this case. I need to know what is this part. Well, if this creates a 90-degree angle, I'm going to take 90 and subtract that amount, and we have approximately 86. So north 86 degrees east.